Imagine an underwater avalanche moving faster than a car on the highway. A wall of sand, mud, and debris racing across the seafloor for hundreds of miles, carving enormous valleys beneath the ocean. These hidden valleys are called submarine canyons, and some of them are bigger than the Grand Canyon, much bigger. They transport sediment from continents to the deep ocean, feed entire ecosystems, and in one place, they even create some of the biggest waves ever surfed on Earth. To understand how these massive underwater landscapes form, we first need to talk about the powerful forces that carve them. One of the main forces that creates submarine canyons is something called a turbidity current. Turbidity simply refers to water that contains a large amount of suspended sediment like sand, silt, and clay. When rivers carry sediment into the ocean, or when large amounts of sediment accumulate along the continental shelf, this material can suddenly collapse and begin moving downhill underwater. Because this sediment filled water is denser than the surrounding seawater, it flows downslope along the seafloor like an underwater avalanche. Once these flows begin, they can travel incredibly fast and over huge distances. Some turbidity currents have been measured moving 10 to 20 meters per second, and certain events have traveled hundreds of kilometers across the seafloor.
As this dense mixture rushes downhill, it erodes the seabed beneath it, cutting channels into the continental slope.
Over thousands or even millions of years, repeated turbidity currents deepen and widen these channels, gradually carving enormous submarine canyons. These underwater avalanches usually start when something disturbs sediment near the edge of the continental shelf. Major triggers include river floods delivering massive amounts of sediment, earthquakes destabilizing underwater slopes, storms stirring up sediment, or the collapse of sediment piles near river mouths. Large rivers like the Congo, Ganges, Brahmaputra, and Indus supply huge amounts of sediment into the ocean, making the nearby submarine canyons some of the most active in the world. Eventually, when these turbidity currents reach flatter parts of the deep ocean, they slow down. When that happens, the sediment settles out and builds enormous deposits called submarine fans.
Over time, these fans can become some of the largest sediment structures on Earth, stretching thousands of kilometers across the ocean floor.
In other words, turbidity currents act like a giant conveyor belt, moving sediment from continents through submarine canyons and depositing it far out into the deep sea. And some of the most impressive examples of these systems exist in the submarine canyons around the world. Deep off the coast of Central Africa lies one of the most active submarine canyons on the planet, the Congo Canyon. It stretches about 174 miles into the ocean, with walls rising over 3,000 feet high and a bottom plunging 8,600 feet deep. And it's not just a trench in the sea, it's a highway for one of the world's mightiest rivers. The Congo River feeds this canyon, bringing in around 41,000 cubic meters of water every second. That's enough to fill about 16 Olympic swimming pools every second. Its drainage basin covers 1.4 million square miles, roughly the size of India, funneling an incredible amount of sediment straight into the canyon. The sediment includes sand, clay, and large amounts of organic carbon and plant debris from the Congo rainforest.
All of this eventually pours into the Congo deep sea fan, which spans 116,000 square miles, or around the same size as Arizona, the sixth biggest state in the US, and stretches over 400 miles into the Atlantic Ocean.
Inside the canyon, turbidity currents race downhill like underwater avalanches. Some move as fast as 8 meters per second, nearly 18 miles an hour. These currents have even snapped undersea communication cables, but they also fuel life. Sunlight cannot reach these depths, so the ecosystem relies entirely on what the river delivers. Microbes feed on organic carbon, shrimp and crabs feed on those microbes, and deep sea fish feed on them. It's a thriving food web built from material that started as rain falling in the Congo rainforest thousands of miles away. The Congo Canyon likely began forming 5 to 10 million years ago, and it's still evolving today. But not all submarine canyons are carved by rivers. Some form in completely different ways. Hidden beneath the turquoise waters of the Bahamas lies one of the most dramatic underwater landscapes on Earth, the Great Bahama Canyon. It stretches about 140 miles, with walls plunging as much as 14,000 feet from the surrounding banks. That's as tall as stacking 9 Empire State Buildings on top of each other, and then some, creating one of the largest vertical underwater cliffs on the planet. Unlike river-fed canyons like the Congo, this one formed from the collapse of the Bahama Banks, massive shallow platforms made of limestone. Over millions of years, the weight of carbonate sediments and erosion from powerful ocean currents caused huge sections of these platforms to slide into the deep ocean. The surrounding banks constantly produce carbonate sediment made from coral fragments, shells, and limestone sand.
As this material slides into the canyon, it forms carbonate fans at the bottom.
This canyon is also a highway for water. Tidal currents move through the canyon year round at speeds of roughly zero point 0.5 to 1 meter per second, or 1 to 2 miles per hour, circulating water between shallow banks and the deep tongue of the ocean basin. This steady flow supports deep coral reefs, sharks, groupers, and sponge communities. While the Bahamas Canyon formed from collapsing carbonate platforms, other submarine canyons were carved by an entirely different form: glaciers. Far across the Atlantic, off the coast of Europe, lies Wittard Canyon. It stretches about 80 miles, with depths reaching roughly 5,000 feet, around 4.5 Eiffel Towers tall. This canyon formed during the Ice Ages, when massive glaciers extended across the continental shelf. Glacial meltwater and sediment carved deep channels into the seafloor. This sediment here is mostly glacial mud, shelf sand, and biological debris. Instead of turbidity currents or tidal flow, Wittard Canyon is shaped by internal tides and deep Atlantic currents that push nutrients up the canyon. This process fuels one of the most diverse deep sea ecosystems in the region, including Lophelia pertusa coral forests, deep sea sponges, sharks, and swordfish. But some submarine canyons are powered by rivers draining the highest mountains on Earth. Far off the coast of Pakistan lies the Indus Canyon, stretching roughly 90 to 110 miles, with depths of 8,000 to 10,000 feet. It is fed by the Indus River, which drains the Himalayas and Karakoram Mountains, two of the fastest eroding mountain ranges on Earth. Tectonic uplift, heavy rainfall, and glacial melt send massive amounts of sediment downstream. The sediment feeds the Indus Fan, an enormous underwater deposit covering about 1.1 million square kilometers, roughly the size of Texas. In some places, the sediment here is more than 6 miles thick, or 3 times the height of Mount Everest. During floods and monsoon seasons, turbidity currents rush down the canyon at 4.5 to 11 miles an hour, carrying sediment hundreds of kilometers into the deep ocean.
And even larger systems exist where multiple giant rivers combine.
In the Bay of Bengal lies one of the largest submarine canyons in the world, the Swatch of No Grounds. It stretches roughly 185 miles long and about 45 miles wide. This canyon is fed by the Ganges Brahmaputra river system, the largest sediment producing river system on Earth. Monsoon rains, Himalayan erosion, and landslides send hundreds of millions of tons of sediment into the ocean each year. That sediment eventually feeds the Bengal fan, the largest submarine fan on Earth. It stretches over 1,850 miles, roughly the distance from New York to Los Angeles, and sediment there reaches 10 miles thick. Upwelling currents bring nutrients toward the surface, creating rich feeding grounds for marine life. Large fish gather here, which attracts whales like Brutus whales and Irrawaddy dolphins, making the canyon an important seasonal feeding area. But one submarine canyon is famous for something completely different. Instead of shaping ecosystems or sediment flows, it creates some of the biggest waves on Earth. Just off the coast of Portugal lies Nazaré Canyon, one of the deepest submarine canyons in Europe. It stretches roughly 130 to 140 miles and plunges down to over 16,000 feet. What makes this canyon famous is how it amplifies ocean waves. Waves traveling through the deep canyon move faster than waves crossing the shallow continental shelf. When these wave fronts meet near the coast, they focus and concentrate their energy. This process can produce waves over 30 meters tall, more than 100 feet high. These enormous waves have made Nazare one of the most famous big wave surfing locations in the world. During the winter months, powerful Atlantic storms send long period swells toward the coast. And when those swells interact with the canyon's unique underwater shape, gigantic rideable waves can form. Surfers from around the globe travel here each year hoping to ride some of the largest waves ever surfed. Submarine canyons are some of the most powerful and least visible landscapes on Earth. Carved by underwater landslides and sediment flows over thousands to millions of years, they shape ocean currents, transport sediment across continents, and even influence the massive waves we see along certain coastlines. From the depths of the ocean floor to the beaches above them, These hidden canyons play a much bigger role in our planet's systems than most people realize. And while we may never see most of them with our own eyes, their impact is felt all around the world.
If you liked this video, be sure to subscribe for more interesting content like this. Thanks for watching.